Yes, good afternoon. This is Mr. Lanre from Tender Care International Group of Schools. We are located here in Cairo, Egypt. I'm here to take grade 8 students in mathematics. So I hope you enjoy the class with me. So in the last class, we were dealing with a very beautiful topic. Okay, we're dealing with applications and relations. So I gave you homework or work to do from home. So we just quickly do the correction. Then we move to what we're supposed to do today exactly. Today we're supposed to, we'll be doing transversals and medians, but we'll start with transversals first before we get to median. So regarding the correction for the last work to do, we'll just give that to you again. Suppose that f such that A binds with A, known by the rule or arrow diagram. This is the arrow diagram, 0. This is the domain and the codomain. We are A. We have 0, 1, 2, 3, and 4. We have 0, 1, 2, 3, and 4. From the question, 1 binds with 0, 0 binds with 2, 3 binds with 3, 2 also binds with 3, and 4 binds with 9. Okay. So the first question says, find A, f of 0, B, we have f of 2, C, we have f of 3, and D, we have f of 4. The other question says, express f, the application f, in form of ordered pairs. So with what we have on the board, this is more of a direct question. This is something under image, okay, on that very topic, application. I told you the image of an element is the other element. That element is arrowing in the codomain. For example, f of 0 now is arrowing which of the elements in the codomain 2. So it means the image of 0 here is 2. And f of 2, that will be, let's check, that will be 2 and 3. Because f of 2 will be 3, sorry. Then f of 3 also will be 3, then f of 4 will be 1. So this is these are the answers to the first part of the question. And the second part says, express f in form of ordered pairs. It means the ones that are connecting together, they are binding together. So even from the image, you can easily write that out. So without wasting much of the time, 0 binds with 2. This is 1, and 1 binds with 0. Then we can also see that 2 binds with 3. Then 3 also binds with 3. So I think these are all the other pairs we have for this very application. So you can check on our YouTube channel to get better understanding of this very correction. So I will rub this part of the board and just give me like a few minutes to rub that off, because the technical team will take a picture of this and get things done. So now we'll move ahead. I'll have to rub this off totally so that we can go to a new topic. Like I've told you right from the beginning. beginning, I said we'll be dealing with transversals and medians. So I'll write the topic now on the board, transversals. And medians. Don't forget today's date is the 9th of June 2020. Okay? And don't forget this is the pandemic era. So try as much as possible to stay safe. So we have theorems under transversals and medians. The first theorem we'll be dealing with, that is theorem 1. Equal intercepts if there are 3 or more parallel straight lines and the intercepts made by them on any transversal are equal. Come on. Then the corresponding intercepts on any other transversal are equal. So these are just words cooked up grammatically, so it's very simple and direct. We'll have a diagram on the board to see what exactly we are trying to say. With this diagram you understand better what we are talking about. So we have first parallel line, second parallel line, third parallel line, fourth parallel line. So in previous classes, I want to believe I told you that transversals are lines that intersect parallel lines at certain or at different points. Now, we have 2 transversals here. We have H and we have HI and we have KL. So the first point where they are intersecting on the first transversal HI, we have point A, we have point B, we have point C, and we have point D. And here we have on the other side E, F, M, and N. Get a red marker to trace this out. Okay,
listed.
So just to make the diagram perfect,
so that there will be no any mistakes and be able to get the explanation correctly.
okay. So point X, point Y, and point Z. Given EA is parallel to EF, parallel to CM, parallel to DN. Okay. We have AB is equals to BC is equals to CD. And we have KL is a transversal. RTP, that is required to prove. EF equals FM equals MN. By construction, from points F, M, and N, draw straight line, straight lines parallel. Straight line HI to meet by extensions of AE, BF, and then CM at X, Y, Z respectively. Therefore, XF equals AB to opposite sides of the parallelogram. I'm just trying to manage this part of the board so that I won't have to rub off anything over there. Then also YM was AC, opposite sides of the parallelogram. AB equals BC, given SF is equals to 1 in triangle XEF and triangle YFF and XEF is equals to YFM. That corresponds.
SE is parallel to YF. And XFE is equals to YMF. I correspondence as well. As far as XF is parallel to YF. Therefore, the two angles are two triangles rather. The two triangles are equal. Side angle. Therefore, EF is equals to FM.
So that is the all notes we have for today. So now we have the whole proof on the board. Then we'll be explaining one after the other why this is equals to this is parallel to this, and why this is this and why that is that. I've always told you, when you have anything that has got to do with proof, it is important, I mean very, very important, that you understand first what is required of you to prove. Now, theorem 1. If there are 3 or more parallel straight lines and the intercepts made by them on any transversal are equal. Now, the very first question that you might want to ask me is, which of the lines is a transversal or are transversals? Or which of these lines are parallel lines? HI is a transversal. KL is another transversal. So it means we have 2 transversals in this very diagram. And this line is always going to be called a transversal because it's cutting through 2 or more parallel lines. Do you understand? Now, it is required to prove, because it has been given already, according to what we have, that if we have a transversal cutting through parallel lines, we are not talking about transversals now. We are talking about a single transversal line. For example, HQ. It is proven already that AB will be equals to BC, and BC will be equals to CD, and so on and so forth, depending on the number of parallel lines we have. Now, the corresponding side, which is like the other side of it, we want to show and prove that the other transversal cutting, now we are talking about another transversal entirely now, transversal KL. Now, the points E and F, the distance, we want to prove if it is, or we want to know if it is equal to Fn, which means, as we have said, that AB is equals to BC, we want to prove as well that EF can also be equal to Fn. So get that at the back of your mind, and don't forget it. Now, in anything that has got to do with proof, we will be given some certain instructions. Now, starting with this, they said given EA is parallel to BF, and BF is parallel to CN, and CN is parallel to DN. Don't forget, when you see 2 lines like this together very close, it is called parallel. It means they are trying to show you the lines that are parallel in that particular shape. Now, where is EA? This is points E and A. So between these 2 points is a line. This is points F and B, or B and F. This is another parallel line. So now we have 2 parallel lines, AE, and 2 parallel lines, BF. we have a parallel line AE and another parallel line BF, making two parallel lines. Now, they are trying to say that all these parallel lines, as we can see, AE is equals to B is parallel rather to BF, BF to CN, and CN to DN. So you can see all these lines till eternity, they will never meet. This is why they call them parallel lines on the same plane. Now, if you see line KL, it's cutting through the parallel lines. Why? Because it's not parallel to them. That is why we call it a transversal. So I want to believe with this you are now able to understand what a transversal is and parallel lines. So parallel lines always cut through the transversal lines always cut through the parallel lines. Now, let's move ahead. AB equals to BC equals to CD. This is another thing that we have been given according to the first transversal that says the spaces between points A and B on the length between point A and B, B and C all are equal. Now, I've told you before as well that RTP means required to what? To prove. It means you are required, what is required of you to prove? That is EF equals FM and FM equals MN. We have been given already that these all are equal. Now we want to prove that the opposite side of it, they are also equal. How can we do this? Now, by construction, don't forget when you are dealing with proof, you always construct from points F, M, N. Now, where are these points in this very diagram? F, M, and N. This is F, M, and N. It says, draw straight lines parallel to straight line HI. Don't forget, line HI is a transversal. So we are asked to construct a line that is parallel from all those points to line HI. Now, that is why we have this construction in blue line. From point F now, we have constructed a line to touch a point at the extension of what? AE. Extension of AE means AE should have stopped here, but we extend it, which means we elongate the line so that a point could be on that very line. That is point X. Now from this point, we have constructed F to X, M to Y, and N to Z, respectively. Now, therefore, XF equals what? AB. What is the relationship between them? When we say two things are equal, it means they have a similar relationship. So it means, according to the instruction, it said they must be parallel lines. So we can say XF is parallel to AB. That is the relationship between these two lines. And aside that, if we check very well, the shape we have now is more of something like this. Now, let's look out for our point B. This is point B, this is point A, this is point X, this is point F. Now, this shape now looks like what? A parallelogram. And opposite sides of a parallelogram are always equal. It means this is equals to this, and this is equal to this. So that is the main relationship, apart from the fact that there are two parallel lines. According to the rule guiding all parallelograms, that two opposite sides are equal. So that is why X or XF or FX is equals to AB or BA. That is what we have here. Two opposite sides of a parallelogram. Now, also, YM equals to BC. YM, where is point Y, where is point M? Is a line. Now, YM equals to BC. The two, the exact thing that links them together are one, there are two opposite sides of the parallelogram as well, and there are two parallel lines. So that's that about that. AB equals to BC. Where is point AB? This is point AB, and this is point BC. That is given already. And XF is equals to YM. XF is equals to what? YM. Why? Because they are both two opposite sides of a parallelogram cut by different transversals. Now, going further, I said in triangle XEF and triangle YMF. Don't forget what is required to prove is that EF is equals to FM. In triangle XEF and triangle YMF, where are these two triangles? XEF and what? YFN. Now, these are two triangles, okay? Two different triangles. But we want to check if they have any relationship or things that are similar to another. Now, angle XEF, excuse me, angle XEF equals angle YFN. Now, they are trying to compare the two triangles now. Triangle XEF and triangle YMF. Now, in these two triangles, they are bringing out two angles in the triangle. Don't forget, triangle is different from angle. So when we are talking about triangle, we are talking about the O shape. When we are talking about the angle, we are talking about the angle or angles in a triangle. Now, don't forget, the letter at the middle is the one that carries the angle. Angle XEF. So it means we are talking about this particular angle, XEF. This angle is equals to angle YFN. YFN. Now, they said the relationship that makes them equal is because they are corresponding angles. They are corresponding angles. Corresponding angles are formed when we have two parallel lines on a straight line. Now, if you check now, according to the proof, they said because XE is parallel to YF. XE is parallel to YF. If you see there are two parallel lines, this is the only thing now joining them together. If we turn this shape the other way around, then you will get the true picture of what it is. If you have the understanding of what corresponding angles are. Now, I want to try to turn the shape upside down. If we turn it, this will be a straight line. This straight line. So, this will be more of our EX, and this will be FY, and this is the extension now of EFN. Let's say at this point now. So let's say this is point N. So, and don't forget, we said already that XE is parallel to line what? AB. So it means they are all parallel lines based on the instruction we'll be given already. So now, how do we know they are corresponding angles? Now, this is the angle inside E, and this is the angle inside F. So when you have angles arranged in this form, and we have different parallel lines splitting them, we call them corresponding angles. So that is that about that. So we have been able to prove that angle XEF by correspondence is equals to what? Angle YFN. Now let's go further. Angle XFE, that is XFE, is equals to angle YMF. XFE, we are talking about, let me use another color of marker. Let me see if I can get a red marker. Okay, I have it with me, sorry. So we are talking about angle XFE. XFE. This angle equals to what? This angle. Also by correspondence. Okay? So if we turn the shape the other way around, now you will see why it is correspondence, because this is parallel to this. Because XF is parallel to what? To YM. Now, don't forget we are trying to bring out the similarities, okay, or the comparison between the two triangles, SCF and YNF. Now we've been able to get two equal angles. And don't forget we have a side that is equal already. That is XF is equals to YF by proof. So now, the two triangles are equal. We call them congruence triangle. How are they equal? Equal. One side is equal. When you have two things that are equal, or three things that are equal in a triangle, either two sides equal or two angles equal, or the three sides are equal, we call them congruence triangles. So with this proof now, we can say EF is equals to FM. It's as simple as that. So if you want to have a better understanding, don't forget, before I even go there, it is required to prove that EF is equals to FM, and that is what we've done here. And extensively, FM is also equals to what? MN. So that will be your work to do from home or homework. So I want to believe with this explanation, you now have an understanding of how to prove or how to explain when you have two transversals cutting different parallel lines. And don't forget, to have a better understanding of today's topic, go on the YouTube channel for the school, that is Tender Care Motorstolic written together. And of course, you'll be able to get the teaching for today and other teachings as well from other staff. Don't forget, in this time of pandemic, you need to continue to stay safe, stay home, wear your mask, and do the necessary. Thank you, and God bless you. We'll meet again.